So in this video, we're going to talk about how to describe transformations of absolute value functions. So what we talk about when we say transformations is that within a family of functions, every possible function represents a transformation of the parent function. And you've already gotten an introduction to this back in Algebra 1 when you studied linear and quadratic functions. So remember the analogy that I used is I said, well, our parent function is kind of like vanilla ice cream, right? And then we can add one flavor if we want, right? We can get chocolate chip or we can get strawberry. Or if we want, we can add more than one flavor. We can get mint chocolate chip or we can get strawberry banana. So it's the same idea with parent functions. So here I'm using quadratics as an example. So we can take the quadratic parent function, f of x equals x squared. We can shift it down 2, right? That's one transformation. We can shift it right 3. Or we can take this parent function, we can make more than one transformation. Like we can vertically stretch it. We can shift it left 1. We can reflect it and we can shift it up 1. And so we can do all sorts of things like that. So what we're going to do today is we're going to take the absolute value parent function and we're going to look at different transformations. So transformations is a very important topic in Algebra 2, and it's something that you're going to see revisited a lot. So if you get familiar with transformations now and what the different variables represent, it's going to be a lot easier for you as we work through our upcoming units. So remember, the absolute value parent function looks like this. It's f of x equals the absolute value of x, and it has all of these following key characteristics. So now let's look at some transformations. So basically, since the parent function is f of x equals the absolute value of x, every other absolute value function is considered to be a transformation of this original function. So all the transformed functions will have the form f of x equals a times the absolute value of b times x minus h plus k. All right, so we're going to learn about what this a, b, h, and k represent because they're all going to be constants, but they're going to give us information about how the function has been transformed. So here's a chart that I think is going to be very helpful to you as we work through transformations. What this does is it tells us what a, b, h, and k are going to do to our original function. So what happens with a? Well, a is always going to be some sort of vertical change because any number that's on the outside of the absolute value is going to change our function in a vertical manner. So a, if it's bigger than 1, it's going to be a vertical stretch. If it's a number that's between 0 and 1, it's going to be a vertical compression. Also, if a is negative, it's going to reflect our graph over the x-axis. Okay, so b is a value that's inside our absolute value. Okay, so any value inside is going to be a horizontal change. So b is like, and the thing with horizontal changes is they kind of do the opposite of what we think. Okay, so if b is between 0 and 1, it's actually going to be horizontally stretched, which is actually making our graph wider. Okay, if b is bigger than 1, it's actually going to be a horizontal compression, which makes our graph like narrower. It'll be a reflection over the y-axis when b is less than 0. So also we can have a value of h, okay? H is inside the absolute value, so it's going to be a horizontal change. Like I said before, horizontal changes kind of do the opposite of what we think. So if this looks like an x plus h, it's going to go left, okay? I know you guys are used to thinking, well, positive is to the right, negative is to the left. But with horizontal transformations, we kind of do opposite. So plus h is going to go to the left, minus h is going to go to the right, okay? And now we have our k, which is outside the absolute value. So since it's outside, it's going to be a vertical change. Our graph will go up when k is positive, and it'll go down when k is negative. Okay, so we're going to look at some examples, and this is going to make a whole lot more sense. So what we're going to do is let's start off by graphing all of these functions in Desmos. Okay, so I'd like you to pull up Desmos and then graph all of these functions. So we have f of x is the absolute value of x, which is our parent function. And then 2 times the absolute value of x, 1/2 times the absolute value of x, and negative absolute value of x. Okay, notice what happens here is I've transformed a, right? So I've changed the number that's in front of my absolute value in all of these functions. And I want to think about how transforming the value of a is changing my function from the parent. Okay. So what I've done here is I've taken screenshots of all my graphs in Desmos. And what I'll do is I'll always graph the parent function using these dotted lines so that you can see what I'm comparing to. So I have f of x equals the absolute value of x, which is the parent function. And in this first graph, I have 2 times the absolute value of x. And look what it does to my graph. It's almost like if you imagine I took like, a hold of both of these endpoints and I kind of pulled my graph up, right? You can see that's why it's vertically stretched. Notice that my graph looks taller. So it's like it's been pulled up in the vertical direction, okay? So that's what happens if A is bigger than 1. Well, if A is between 0 and 1, like here I have this 1/2, that actually vertically compresses my graph, right? Because notice that this graph in green here is shorter than my actual original graph. So it's kind of like it's been pushed down in the vertical direction. And then also if A is less than 0, okay, if A is a negative number, like here I have negative absolute value of x, that reflects my graph over the x-axis, okay? You can see that if you imagine the x-axis like a mirror and I take this parent function, I can actually reflect it over that, and that's how I get the graph of j of x equals negative absolute value of x. So that's the effect of A. So A is going to be a vertical stretch or compression or a reflection over the x-axis. So now let's try graphing these functions in Desmos. Let's graph the absolute value of x, the parent function, and then the absolute value of 2x, the absolute value of 1/2 x, and the absolute value of negative x. Notice that in all these functions, I'm transforming the value of b. So what we're going to figure out is what happens when we transform b in our functions. So here I have screenshots of all my graphs in Desmos. So you can see that when b is a value that is bigger than 1, my graph is horizontally compressed. So what I mean by horizontally compressed is kind of like I, squished my graph in from like the x direction, okay? And so it makes it narrower, right? Because I pushed everything in from my horizontal direction, like this way, and it made my graph narrower. If b is between 0 and 1, my graph is actually horizontally stretched, okay? Because you see it's been wider, right? It's like it's been pulled out in the horizontal direction. And then also if b is less than 0, my graph is reflected over the y-axis. So you may be looking at this graph and wondering where the parent function is. Well, what happens is since my parent function has reflectional symmetry with respect to the y-axis, when I reflect it over the y-axis, it actually looks like the exact same graph, okay? But that's what happens if b is less than 0, you get a reflection over y. So b will create a horizontal stretch or a compression or a reflection over the y-axis. So now let's try graphing these three functions in Desmos. Let's graph the absolute value of x, the absolute value of x plus 2, and the absolute value of x minus 3. Notice that in these functions, I'm transforming the value of h. So let's think about what happens when we transform the value of h. So here I have my screenshots. Well, notice that when I have the absolute value of x plus 2, my graph actually goes to the left, right? So that horizontal change is what I told you. It kind of does the opposite because we see that plus and think, well, maybe it's going to the right, but it's actually not. Okay, plus makes it goes to the left. And if it's an absolute value of x minus 3, it's going to go to the right 3 units. Okay, so that's the effect of h. H is going to shift our graph left or right, but think opposite when you're looking at h. Okay, so if you see a minus sign, it's going to go to the right. If you see a plus sign, it's going to go to the left. So now let's try graphing these functions. Let's graph the absolute value of x, the absolute value of x plus 2, and the absolute value of x minus 3. Notice that here I'm transforming the value of k. So let's think about what happens when you transform k in all of these functions. So k is going to shift the graph up or down. Okay, so if we have the absolute value of x plus 2, my graph is going to go up 2. And then if we have the absolute value of x minus 3, the graph is going to go down 3. Okay, so plus k is going to go up, down k is going to be minus. So now I have all of these charts posted in our study guide. So you can use whichever form of the study guide makes sense to you. Some people prefer this chart that has, all of the different A, B, H, and K and all the effects listed out. Some people like this flow chart, and I'll show you how to use this flow chart as we work through an example. You basically look at where the number is located in your absolute value function, and then you figure out, if it's going to be a vertical or a horizontal change, and then what type of change it's going to be based on if it's adding or, multiplying in your problem. Okay, so we'll look at this in more detail when we work through some examples. And then you also have this chart right here that shows you different, types of transformations, and it gives you some examples over here also. So use whichever form of the study guide makes the most sense to you. So let's try describing the transformations that occur when the function f of x equals the absolute value of x is transformed to g of x equals the absolute value of x plus 3. Okay, so here's how I go about solving these problems. So I look at the parent function and then I look at the new function and I just say, okay, well, what's changed? Okay, what's different here? And I notice that this plus 3 is like my change, right? So I'm just going to underline that plus 3. And then I'm going to think about that in terms of a, b, h, and k. So like, what is that? Well, it's inside my absolute value and it's being added to my function, so it's going to be an h. Okay? And then what this chart tells me is that h is going to be a horizontal shift left or right depending on the sign. So if it's plus h, it's going to be a shift left. Okay? So that's what I do. I just write the plus 3, and then I know that's going to be a shift left 3. Okay, and let me show you how to use the flow chart. If you prefer the flow chart, this is how you would do that. Okay, so the plus 3 is inside my absolute value, right? Okay, so inside means a horizontal change. And then I need to think about whether it's being added or subtracted or multiplied in my function. Well, here it's being added or subtracted, so I'm over here, right? And so that tells me that it's going to be a shift left when I have x plus h. Okay, so if you prefer, you can use this flowchart. Both of these have the same type of information. It's just presented differently. So here's another thing. I want you to realize that Desmos is a very important tool that you can use when you're figuring out transformations, because Desmos basically like gives you the answer, right? So what I would do is I would do this work right here and predict the transformation, but then you can use Desmos to check your work. So if you think it's going to go left 3, like by all means, please graph your parent function and the transform function in Desmos and make sure that it does go left 3. Because sometimes it's easy to get a little bit confused, especially with like the left or right or stretch or compression. So make sure that you're using Desmos to double check your work. It only takes a couple seconds, and I promise it'll always give you the right answer. So now you can go ahead and pause the video and try doing this example on your own. So here, notice the transformation is this plus 2. This plus 2 is a value of k, and since it's plus, it's going to go up. Okay, so if we're using this flowchart, it's outside, so it's going to be vertical. It's being added to my function, and that tells me that it's up when I have plus k. So notice that if I graph both in Desmos, I can see that the graph has been shifted up 2 units. So now let's describe the transformations that occur when the function f of x equals the absolute value of x is transformed to g of x equals the absolute value of x plus 2 plus 1. So what's new here is that I have more than one transformation, right? I have 2 things that have been added into my function. So I'm going to figure out what values these are. So, well, the 2 is on the inside, so that's going to be an h, right? And then my k is on the outside, it's being added, so that's going to be what 1 is. So then I'm going to list these out, and this is just how I do them. I just list out my numbers and think about what the effects are. Well, my plus 2 is inside my absolute value, so that's going to be a horizontal change. It's being added, and that tells me if I have x plus h, it's going to be a shift left. So this is going to go left 2 units. That's going to be the effect. And then my k, well, that plus 1 is outside, right? It's being added or subtracted, and it tells me that plus k is going to be a shift up. So this is going to go up 1 unit, okay? And then as always, I'm going to go to Desmos and graph both functions and see if that's what happens, right? I predicted it's going to go left 2 and up 1. And you can see here that's what happened, right? Here's my parent function. It goes left 2 and up 1. So the vertex is a really good point to compare because it kind of gives you a quick visual of what's going on. So now let's describe the transformations that occur when the function is transformed to g of x equals the absolute 1/3 times the absolute value of x plus 4 minus 5. So what's different here is that I have 3 transformations now, right? I have a 1/3. My 1/3 is in front, so that's going to be a value of a. My plus 4 is on the inside, so that's going to be a value of h. Minus 5 is on the outside, so that's going to be a value of k. So let's list out all these values and see what effect they're going to have on our graph. So the 1/3 is in front. That's a value of a. Okay, it tells me if the absolute value of a is between 0 and 1, it's going to be a vertical compression. Okay, so this graph is going to be vertically compressed. My plus 4 is on the inside, and it is a plus, right? So it's going to be a shift left when I have x plus h. So it's going to be a shift left 4. And then my minus 5 is on the outside. That's going to be a K. And then when it's a minus, it's going to go down. So it's going to go down 5. So here are my predictions. I said the graph is going to be vertically compressed, shifted left 4, and down 5. Okay, let's verify that that is in fact true. So I'm going to graph in Desmos. Okay, I can very quickly see that this graph has been vertically compressed, right? It's like someone squashed down my graph. And it is shifted left 4, right? If I look at the vertex, it went left 4, and it did go down 5. Okay, so you see you can always verify using Desmos, which is a very important thing to do. So here I just want to make you aware of a very, very common mistake that I saw a lot of, okay? Let's think about this question. It says, describe the transformations that occur when the function f of x equals the absolute value of x is transformed to g of x equals negative 2 absolute value of x. Okay, so what I've done here is I've added in an a, and my a equals negative 2. So what is going to happen when I have an a equals negative 2? Well, what happens when a equals negative 2 is there's going to be two changes, okay? The graph is going to be vertically stretched, and it's going to be reflected over the x-axis, okay? So the reflected of the x-axis, that's not the part usually people have trouble with, right? Because we know that if it's negative in front, right, it tells me if a is negative, I'm going to reflect it over the x-axis. But what happens is a lot of times I was seeing that people were saying the graph is vertically compressed since negative 2 is less than 1, okay? What happens is people are looking at this part of the chart and saying, okay, well, I have negative 2 and that's less than 1, so how can it be a vertical stretch? Well, notice here that it says the absolute value of a, okay? So we're not looking at a itself, we're looking at the absolute value of a, and that is what is very important here. So the absolute value of a tells us that we have the absolute value of negative 2, which is actually positive 2, okay? That's how we say that it's a vertical stretch. Okay, so be very careful when you're looking at A and you're trying to figure out stretch or compression. Notice that it says absolute value. Okay, please don't ignore the absolute value because that's when people were getting confused and they were saying, well, A is less than 1, so it's a vertical compression, and it's not vertically compressed. What happens is the negative means it's reflected, and the 2 means it's vertically stretched. So yeah, that's what it says here. So the negative 2, we look at the absolute value, and so the 2 is bigger than 1, so that's how we have the vertical stretch. So, once again, I said if you type this into Desmos, you'll see that that's what's going on, right? So we do see that the graph has been reflected, but notice that this graph is like taller, right? So it's been stretched vertically. It doesn't look like it's been vertically compressed. Okay, so now let's try this example. What are the transformations that occur when we have the function g of x equals negative 3 times the absolute value of x minus 2 plus 4? Okay, so here we have some new numbers that showed up in our equation. So this is a, this is going to be h, and this is going to be k. All right, so what does the negative 3 do? Okay, well, we see the negative, right? Anytime you see the negative, you know you have that reflection over the x-axis, okay? So that's one of those things that we know automatically. If we see the negative, we know we have a reflection over the x-axis. So it's going to be a reflection over x-axis. And then now we need to think about the effect of negative 3, right? So we need to think about stretch or compression. But remember, what we're going to do is we're going to look at the absolute value of negative 3. The absolute value of negative 3 is 3. And 3 is greater than 1. So this is going to be a vertical stretch, okay? So we have reflection and vertical stretch. And then from the 2, right, we have a minus 2. Well, it tells us that when we have an x minus h situation, that is going to be a shift right. So it's going to be a shift right 2. And then we have plus 4, which is our value of k. And so if we have a plus k, we're going to have a shift up. So it's going to be shift up 4. Okay, so these are all the transformations that I'm predicting. So reflection, vertical stretch, right 2, and up 4. So let's go to Desmos and make sure that we've done this correctly. Okay, so I can see already that it's been reflected, right? So that's why my graph looks like it's been, reflected upside down. It is vertically stretched, right? You see this graph is taller than my original. It has been shifted to the right 2 because look at the vertex. It went right 2, and it has moved up 4 because it did go up 4 units. Okay, so see how Desmos can always help you double check your answers. So now you can go ahead and pause the video and try doing this example on your own. Okay, so what changed here? We have a -1/2, a +1, and a +6. Okay, so the -1/2, as soon as you see the negative, that means it's been reflected over the x-axis. Okay, the absolute value of -1/2 is actually 1/2, right? And 1/2 is between 0 and 1, so we have a vertical compression. The +1, remember if we have an x plus h, it's going to be shifted left 1. And then we have a +6, and remember if we have a plus k, it's going to go up 6. So now we're going to double check in Desmos so we can see that it has been reflected, okay? And it is vertically compressed. You see this graph is like, squashed down compared to this original graph. It is shifted to the left 1. If we look at the vertex, it's shifted left 1, and it has moved up 6 units. So there are some questions on the quiz. These are like multiple select questions. And what it does is it asks you to describe transformations in a different method than you're used to, okay? And sometimes people get confused by these questions, so that's why I want to kind of show you how to approach them. Really, it's asking for the same information that we've been figuring out on every problem, but it just looks a little bit different, okay? So what it does is it gives you a transformation, then it says select 4 correct answers, okay? So we know how many answers we need to choose because it tells us. But what I like to do on these problems is like I ignore the answer choices when I'm figuring it out. And I think that's where that creates some of the confusion in these problems. It's like some people jump to the answer choices, but reading through those, it can be kind of confusing. So what I do is I just set this problem up just like we would normally do on every other example. So like I know this is A, this is H, and this is K. And then I describe the transformations in my own words. Okay, so I just do it like we've done every other problem. So the -2, I know it's going to be reflected over x, right? Because of the negative sign. And then I also know that it's going to be vertically stretched, right? Because the absolute value of -2 is 2, and 2 is bigger than 1. And then the +1, right? I know the +1 means it's going to be shifted left 1. Just like we've always been doing, right? And then the +6 means we're going to shift up 6. And so then what I do is like I have the answers written out for myself, okay? I haven't looked at the answer choices yet. Now I'm going to look at the answer choices, but all I'm going to do is match what I already have written down, okay? So I don't care all this other stuff that I say because I'm not going to get lost in their words. I'm just going to, okay, so I'm looking for reflect over x-axis, okay? And that's here, so check. Vertically stretched, that's here, and so I'm going to check that off. Left 1, so I'm just going to find where it says that. And so sometimes instead of shift, they'll say translate. Okay, so translate a left 1 and then shift up 6. They say, okay, translate up 6. So if you do the problem like in your own words and write it out for yourself before going to the answer choices, I think it helps out a lot with these problems. Okay, and then as always, once you've written these out, let's check off our answers. So we said left 1, up 6. We said vertically stretched and reflected. Okay, we can always double check in Desmos and make sure that what we said was correct. So you can see this graph has been reflected. It is taller, so it's vertically stretched. The vertex has been shifted 6 units up, and it did move 1 unit to the left. Okay, so writing things out in your own words can really help out with these problems. So now you can go ahead and pause the video and try this example on your own. Okay, so here we have a 1/5, a -3, and a +2. So once again, I wrote it out for myself, right? So I have a 1/5, so that means vertical compression. -3 means right 3, and +2 means up 2. Okay, so I just checked off three choices that matched what I had written out. And then I'm going to go to Desmos and make sure that I got it right. Okay, so you can see here it is translated 3 units to the right. 2 units up is correct, and it is vertically compressed, right? It looks like someone squashed down this function from the vertical direction. So sometimes we have problems that go in the other direction, right? So usually we're given the equation, and then we're asked to look at the equation and identify the transformations. Well, sometimes it's going to give us the transformations and tell us to write the equation. So what I like to do in these problems is I like to look for important words and phrases that tell me that I have a transformation going on, and then I just highlight, underline, or circle them, okay? And that kind of gives me a guideline on how to write my equation. So for example, it says the function f of x equals the absolute value of x is shifted left 1 and down 3, right? So those are my important transformation words. So write an equation that represents the transformed function. Okay, so now I need to think about what I'm doing in terms of A, B, H, and K when I'm going left 1 and down 3. So let's think about that. Well, left 1, okay, well, that's going to be like I'm going left or right when I have an X plus H situation, right? So I'm going to need like an X plus 1 in order to go left 1. Well, what about my down 3? Down 3 means I'm talking about K, right? So remember, a minus K is going to go down. So that means I'm going to have a minus 3. So I just need to transform H and transform K in order to write this new equation. So my new equation, I'm just going to call it g of x, is going to be the absolute value of x plus 1 minus 3. Okay, so I've written my equation, but I'm not really sure if it works, right? I mean, I need a way to check it out. So how do you think I'm going to figure out if my equation works or not? I'm going to go to Desmos, right? So I'm going to go to Desmos and I'm going to type in this equation and I want to make sure that it is shifted left 1 and down 3. So notice that it does work, right? I did x, the absolute value of x plus 1 minus 3, and it went left 1 and down 3. Okay, so that's how I know my equation is good. All right, let's try this one. So it says absolute value of x is reflected over the x-axis and vertically compressed by a factor of 1/2. Write an equation that represents the transformed function. Okay, so we have reflected over x-axis. Okay, what my study guide tells me is when it's reflected over the x-axis, that means my a is less than 0. Okay, so I need to have an a value that's less than 0. Well, it doesn't so far tell me an a. Let's see what else I have. So it says vertically compressed by 1/2. Okay, so my study guide tells me, well, that means that the absolute value of a is between 0 and 1. Okay, so my absolute value of a, well, that's like 1/2, right? My absolute value of 1/2 is between 0 and 1, but also I need my a to be less than 0. So what am I going to do? Well, if I make this a negative 1/2, right, the absolute value would still be between 0 and 1, but I'd also have that a less than 0. So that's how I'm going to write this equation. I'm going to say g of x equals negative 1/2 times the absolute value of x. Okay, but you know, I just wrote this equation. I'm not really sure if it works. So I'm going to go to Desmos and make sure that this does make sense. Well, I can see that when I type in negative 1/2 times the absolute value of x, it is reflected over the x-axis and it has been vertically compressed, right? Like this graph is not taller, this graph is shorter than my original graph. All right, so now let's try this. The function f of x equals the absolute value of x is reflected over the x-axis, shifted left 4 and down 6. Okay, so how are we going to make all these changes? So reflected over x, well, that means that we're going to need a less than 0. Okay, so a is going to have to be negative. Left 4 means that we need an x plus h, right? X plus h is going to be left 4, so this is going to be an x plus 4. We need a down 6. Well, down 6 means that I need a minus k, right? So that's going to be a minus 6. So let's make all these transformations. So I have g of x equals, okay, well, I need my a to be less than 0, and it doesn't tell me a value of a. So if it doesn't tell you a value of a and you need it to be negative, you just put a negative there, okay? Because that's basically like having a negative 1. Because like, you know, you can see this function, it's basically like 1 times the absolute value of x, right? We don't ever write those ones. So I can just put the negative there and then put my absolute value, and all I've done is, you know, reflected over the x-axis. Okay, so left 4 means I'm going to have the x plus 4 inside my absolute value, and then I have my minus 6 for the down 6. Okay, so g of x equals negative absolute value of x plus 4 minus 6. Let's double check that this works. So we can see that our graph has been reflected over the x-axis. It has been shifted left 4, and it did go down 6 units. Okay, so that's how we know our equation works. So now you can go ahead and pause the video and try doing this example on your own. All right, so we need our function to be vertically stretched by 2 and shifted down 1. So a vertical stretch means our absolute value of a has to be greater than 1. So, you know, here we have 2. 2 is greater than 1, so we're good. It has to be shifted down 1. So down is going to be a minus k, so we have a minus 1. So when we plug in those values, we have an a that's transformed and we have a k that's transformed. So we have 2 absolute value of x minus 1. Remember always it's a good idea to double check in Desmos. And you can see that our graph has been vertically stretched, right? It is taller and it has been shifted down 1 unit. So in summary, remember that absolute value functions all have equations in the form y equals a times the absolute value of bx minus h plus k. We can determine how the graph of the function has been transformed from the parent function by looking at the values of a, b, h, and k.